presentation. Yes, and as you see, I have Stéphanie Brunet, who helped me and who will record the meeting and your presentations. I'll just share my screen for the slide of presentation. Here it goes up. Yes. Yes, and good. So we will wait a bit after 4. Usually people just pop up in the last 5 minutes. So. So good afternoon and welcome everyone. We'll just wait one more minute for the presentation to start with the small introduction. With still people coming in the waiting room, so just and some of our colleagues that should be here are still missing, so I'm just making a small email to make sure they have the link. Okay, so I guess we'll start. So welcome everyone to this third conference of the IDEEE community of ELISA. It is our great pleasure today to receive Anette Kolmos and Michael Enelund. Anette Kolmos from Aalborg University and Michael Enelund from Chalmers University. We had a small change of program for the second lecture, so we thanks a bigger thanks to Michael, who accepted to step in for Kristina Henricson, who unfortunately cannot be with us due to a small personal problem. I'll start. So I am Maxime Thomas from Mintai Tech. I'll start with a small introduction that some of you already saw for these conferences, and then I'll let the floor to our two lecturers. First, as I was saying, this conference is organized by the community IDEEE, which is a community of ELISA. So I'll just make a small reminder of what is ELISA and what is this specific community. ELISA is an alliance of 9 higher education institutions and institutions that are training engineers. And ELISA stands for European Engineering, Learning, Innovation and Science Alliance. And I just put on the slides some missions that ELISA itself decided to tackle, and one of which is reinventing the European engineers, so kind of a vast program. And within this program, ELISA is organized with a lot of work packages and a lot of activities going on. But the particular work package is called the community. And the community is a mission-driven working group within ELISA. So it's a much smaller organization or project within ELISA. And the community I am one of the organizer of is called Innovation and Design in European Engineering Education, so IDEEE. The aim of this community is to contribute to the renewal of what we call design-based engineering education, to change how we trained engineers in design and to explore a bit what could be the link between design and engineering education. So you see below the IDEEE members. So I am one of the organizers, but you see also a lot of other professors from different engineering schools and universities that are committed to this community, and I will come back to the role they play within it. So we have the great pleasure to have them today also with us for this conference. Just a bit of background about the community and the reflection we're conducting within it. As I said, the community is much more focused on the design, the link between the design activity and engineering education curriculum. So the main idea we have, or we shared within this community, is that to tackle the current challenges, engineers will have to provide or put in place new design activities. So there are new design needs to tackle the current challenges. And you may think of all the challenges we have ahead, in particular, those linked with the sustainable goals, but also that engineers today have at their disposal new tools or new design resources. In particular, you may think, and you probably have seen this image on the right, that is from a tool that designed thousands of office tables. And so there are new design resources also for engineers to help them tackle the challenge ahead. And these new design needs and new design capabilities are probably calling for or can be the trigger of a renewal of design-based engineering education, or more precisely, a renewal of how design and engineering education are articulated. And therefore, within the community, we looked into those changes that already happened in history. So you can witness regular change in engineering education due to the fact that engineer wants to design new artifacts or tackle new challenges. And also, we can see today in engineering education changes that are linked or that tries to remodel engineering education to a more design-oriented training programs. So our aim of this community is just to contribute to these bigger movements and to try to think a bit and to reflect on the current change undergoing in engineering education, and in particular with linked with design and innovation. And what we do, some of you already know that by heart by now, we organize this type of conference. So it's the third one that are open to public and already online. So if you want to see the previous conferences, you can go on the website where you registered for this conference. And today we'll have a specific conference. I'll come back to it. More state-of-the-art of project-based learning and all the new initiatives linked to this kind of curriculum. What we also organize within the community, even if it's less clear or from an external point of view, we'll organize a workshop in fall in order to gather a little bit all the thoughts that have been exchanged within this community for 1 year now. And also we have a regular meeting with the member of the steering committee that you saw previously on the slides. One of these meetings is just after this conference, as a reminder for our colleague. Of course, please, if you want to contribute more to one or if the subject is of interest to you, feel free to contact me or one of my colleagues. So I'll not take much longer. Today, I just want to thank you again, Anette Kolmos and Michael Enelun, for agreeing to participate and to give a lecture. As I told you, the main subject today will be much more focused on project-based learning, problem-based learning, and the curricula associated to these ideas. So we'll first have a presentation of Anette Kolmos in Aalborg University and who is a specialist of this type of curriculum and learning. And then we'll have a presentation from Michael Enelun, who is a director of Tracks Initiatives, who you will see, a program of Chalmers University to renew the engineering curriculum, in particular with modules associated with problem-based learning and other initiatives that Michael will tell us. So with these words, Annette, the floor is yours. I'll stop sharing and you may be able to share your screen if everything works well.
Yes, thank you very much. And that is the question, if everything is working well, because I have a computer crashing in the moment. But I hope it will be working for the 20 minutes that I'm giving this presentation. So thank you very much for inviting me. It's always a great pleasure, and it's a special pleasure also to be together with Michael Edelund from Chalmers. Chalmers is one of the universities that we always look at, also when we do project-based learning. So let me start out. I have called my presentation for variation in problem-based, project-based learning. And it's because when we see there has been a tremendous move towards project-based learning, and that is good, but we see that it's very much the same type of projects and problems that the students are working on. So let me see what's going on here. So let me start by a review that has been made by one of my PhD students. It's published in the European Journal of Engineering Education. And what she actually found was that a lot of, when you report in journals, a lot of the problem-based, project-based learning that is implemented, it is at the course level. And you find less examples, less implementations actually at the curriculum level. And that is quite important because many of our courses are are small courses. It's within a discipline. So many of the projects that have been reported here are actually lab projects or projects where students are just, you can say, just applying theories to learn it better, to learn it deeper. So that has been the picture of how it has been implemented actually all over the world right now. At Aalborg University, we have another type of implementation, but it's not to say that we have more variation. We try to get more variation, and I'll get back to that, why it's so important to get variation. At Aalborg University, we have 3 taught courses of each 5 ECTS with individual assessment. And then we have half of the students' time they're working on projects. Sometimes these projects have a relation to the taught courses, sometimes they don't. What is really the issue here is many times that students at Aalborg universities, they are doing these 10 team-based projects over a master program, and they get some kind of introduction during the first year, but somehow they forget about how they actually are working together. They just do it. It becomes tacit knowledge. For some of the learning series, they will say that when you have got tacit knowledge, you have also become really an expert because you know how to do things without thinking. So it's a kind of intuitive practice. But for our students, this is not good enough. In education, our students, they need to be able to conceptualize, they need to be able to transform and transfer their competences from one project to another project. And if they are not similar situations, then you also need to speak to students or need to speak to employees in a new context. And it means that you need to be able to talk about it. You need to be able to conceptualize. So this is a project that we have actually started out some years ago to say what we need here is our students, they need to have much more variation in learning. And the variation in learning, it's actually based in another suite. We are very inspired from Sweden here in Denmark. Franz Martin, who actually also is coming from Gothenburg, from Gothenburg University, not Chalmers, but doesn't matter. And he was saying that we need to have variation in the individual's collaboration. So the variation, it's some kind of a progression of learning experiences. It goes from the individual and it goes for both the individual and the collaborative learning. What is important here is that you need to have a sameness in order to transfer from one area to another area, but you also need to have a difference in order to learn differently. Otherwise, you just repeat your learning. So this is the whole theory actually behind that. When we start to look into variation in problems and projects, we are starting to look into different types of problems. It can be student-driven, it can be teacher-driven, it can be open problems or ill-structured, or it can be narrow problems or well-structured. And normally what we are saying is that on the left side, up in the left corner, we have the problem project, we have innovation projects, we have the unsolved situation, we have the wishes, and down to the right corner, we have more the discipline projects and the courses. What is really important here to understand it is that we are saying that projects and problems are giving, improving, increasing students' motivation. But one key in that is that when students they actually have the space, they are allowed to make their own decisions. Of course, it is within a frame, because otherwise it's not possible to control in an education. But the fact that you have made a decision also makes you much more motivated in following and your inquiry, following your curiosity. So this is one way of actually saying something about variation. Another way is to use the Xenophon framework, where you have the simple, the complicated, the complex, and the chaotic problems. The simple, it is within the disciplines. It is what is easy. It is normally what is known. Of course, students, they need to know something about the disciplines. That's without any doubt. So they need to be able to solve simple problems. They also need to be able to solve complicated problems. And complicated problems, it's also what is known, but you need to analyze there. And it can be to build a bridge. We have built a lot of bridges around the world. That's not the issue. The issue is to situate them and to figure out what is specifically important for the construction of this bridge. Then we have the complexity. And the complexity, it's the context, it's the unknown, problems and answers. And it's really where you have to go out and you need to study. It can be stepping backwards. You are not saying that you need to build a bridge to cross a river. You are saying that it's river crossing. So the students have many more possibilities. Complexity is something that is really getting on the table right now, the SDGs. So that is quite important to train the students in actually working with problems where we do not know the answer. We do not really know the problem. We do not really know the answer and the solutions. This is also an implication of taking risk and daring to be on risky ground, you can say. So, but not everything can be complex. But some students, they need also to be to learn to work in complex settings. The last one is the chaotic. You can say we need to also teach the students how to react fast. The COVID-19 has been a very chaotic situation. Where I would say that the universities have actually, they have survived quite fast and also adjusted to a very chaotic situation. We implemented technology overnight, so that is fine. But these are different types of problems that we are working on, and the whole the whole presentation here could be about that. I will not go more into that. Just say that we're using different frameworks actually to categorize, to understand different types of problems. Then we also have different types of projects. And we have two dimensions, one dimension on teams and network, and another dimension on interdisciplinarity. And the discipline project, this is what we found in the courses and what is the most widespread, you can say right now. It is with what we also need to learn. So we have really at Aalborg University, really a lot of discipline projects. We also have what we call multi-projects. I'll go in and give you examples of that afterwards. And then we have interdisciplinary projects, and we have narrow and broad interdisciplinary mega projects. With the more, it is where different student groups are working together. So it's not only collaboration within one team, but teams and network. With more, it is collaboration both within the team, but also among a group of teams. So a discipline project, well, it could be the anti-sway system for ship-to-shore crane. So we make a better working environment for people at the harbor front. That could be one discipline project. A multi-project, one of the examples that we have, it's actually the Giraffe project. It's a project where students at computer science are working on an app for autism, for kids with autism. And they have been working with several groups where they split the work in different ways, working on that app. So it's a very good, has been a very good project. The interdisciplinary project, it's for one team, and it's also an example could be for media technology, for example. They're doing a sustainability city game designed as a medium and catalyzer for learning activities. And it's where the students, they need to go out. It's for school kids, and they need to go out and understand how are the school kids actually learning, what do we know about that, which symbols are we going to use, etc., etc.
Is it all right? I am.
Yeah, something is happening here. I don't know what is happening. Okay, sorry. But we have two types of mega projects. We have one type of mega project where we call it more narrow mega projects. It's narrow interdisciplinary projects. It's where it's much more combined with interdisciplinarity and a system approach, where the students are really working on a device, they're working on a product. That is really embarrassing. This is what is going on here. I don't know. And this project, it is a satellite project where students are working on satellites, and they actually have several times they have satellites up in orbits. So it's a project where they are doing the pre-phase with all the requirements. They do a prototype, and the last group do the real thing and get it up into orbit.
We are still seeing your screen, Annette.
Yes, it's fine. It's fine. It's fine. Don't worry.
No worries.
But you cannot hear?
No, we cannot hear what you were saying. Sorry.
You cannot hear anything. Okay. What is going on? How do I do that? Then we have to go like this. You cannot hear anything. Okay.
No. Now it's all right.
But you, yeah.
Now we can hear you, but
but
we cannot see your slide anymore.
Yes, I know. My computer is getting more and more crazy. I'm so sorry. Then I would actually prefer not to put it into presentation mode. If this is okay, that you can see it like this. So what I'm saying is here is that another product is actually of these mega products, more narrow mega products. It's the Industry 4.0 Smart Lab, where we have students from robotics, automation, electronics, computer science, and management working together. And they're working together on developing a much more smart production. So that is a different another kind of example. Then we have the mega products, and the mega products are what we call the broad interdisciplinary products. The broad interdisciplinary products are with student groups from social science, from humanities, from the two engineering faculties. We have two engineering faculties at Aalborg University. And just to give you an example on simplifying sustainable living, what they have been doing. It is, if we look at, we have a focus on the simplifying sustainable living. We have some challenges: waste, green consumption, transport, etc. And it can be waste handling at Aalborg University, or it can be waste handling in private households. And the waste handling in private households, there we have student groups working on how to do that, but from each their subject perspective. It can be architecture and design, working on the design of the boxes. It can be sustainable design, working on the logistics. It can be biotech, doing what do we do with all the bio waste, etc., etc. So there are many different student groups are working on each their projects, but trying to learn from each other that actually what we do with the bio waste, it is also has consequences for how we are designing the waste boxes. So that's just another example. So when we have done a lot of research on this, and this research also illustrates very clearly that students they need facilitation support as soon as we go into something that is interdisciplinary. They expand their perspective to and understand the discipline much better, you can say. But they also actually are running into the complexity in the problems and processes, and it's really difficult for them to exchange and suddenly to use their product experiences from the teams, from the single teams, to suddenly to manage a lot of teams. So this is something that we are working very heavily on now at Aalborg University to develop that further. We have other type of projects. This is a project that is going on at the second semester at the Eng faculty. They have this with the floating wind turbines. They have the electric car they are working on. They have this with the heated stones. And so already at the second semester, we try to do something that is more with a system perspective and which is easier for the students to understand. What is really difficult for engineering students to understand, it is when it is more the complex problems and they have to go from the abstract to the concrete. They prefer our engineering students to have something that is specific so they know why it is and what it is they're going to work on. Just a few more words and then I will stop. It is actually that what we are trying to do is also really to improve the PBL competences, because when you have variation, that is fine, But if students are working in small teams, big teams, sometimes in mega projects, sometimes in discipline projects, what they really need to do as well, it is also to share and to compare their experiences. What is it that they can learn from this? And we have been doing that for a long time, looking into what kind of generic competences is it that our students are learning. And if we look at the literature review, it says teamwork, communication, problem solving, project management, etc. And what we have been doing is to actually ask our study boards to put into the education, to put in and formulate specific goals for engineering students. What is it they want to out their students to learn? We do that by having both an PBL introduction, but then they reflect throughout the curriculum on how they have improved their collaborative competences, how they have improved their interdisciplinary competences, etc., etc. So this is something new, and they end up actually with having, you can see here that in the beginning we have an introduction course. At the advanced level, we have experience with variation in different types, and we have workshops to facilitate that. And in the end, at the 8th semester, 9th semester, they have to write up their competence profile, which is some kind of their own self-assessment. What are they really good at? What have they been working on here during the whole study? So this is something that is new at Aalborg University, something that we are working on. Right now, for these PBL competence profiles, it is so that it is us as lecturers, as university staff, that is actually responding to these profiles in order to the students, they become more aware of the competences they have gained. But what we want to do during next spring, it is to also get a whole group of external examiners coming in and giving response from the employer side. Because as I said in the beginning, our students, they are very good at projects, but they forget about it. They don't know how to speak about it. So this is one way actually to increase their conceptualization, to increase their understanding of their own team practice, their own collaborative practice. So what we are aiming at, it is a curriculum where we have variation among different programs. So where we have the green ones, it is the discipline and multi-projects. We have interdisciplinary projects, we have narrow interdisciplinary projects, and we have these broad interdisciplinary projects, and we have many more types of projects. But it's really important that we students have the possibility of having different experiences throughout the study. And that we also facilitate their comparison of these different experiences in order for them to both learn project management, but also leadership. So I think I will stop here. Thank you very much. And my computer didn't crash.
Thank you very much, Anette. Thanks to your computer also, not to crash. We were a bit worried before the lectures start. If in the audience there are questions for Anette, please raise your hand. We have plenty of time for discussion before the second lecture. So, first question is always the most difficult, but Pascal, I see you want to.
Can I ask the audience a question?
Frido, I think.
Okay. Yes, please, Annette, and then we'll see if
what is your outcome out of this? The projects that you are working on and having in your engineering curriculum, what kind of projects are these? Are these discipline projects, or are you already at a stage where you have a practicing interdisciplinary projects?
Who wants to answer? Because there will be different answers, probably.
Maybe just to contribute to the discussion, the project we have here in École des Mines is there is, just like you described, there are a progression from projects that are mono or intradisciplinary to projects that are interdisciplinary, and even projects where the disciplinary attachment is unclear and students have to learn how to refer to certain disciplines when they are. And precisely my question would be, what struck us when managing this project is the necessity to be backed by a research lab or a research center that can coach and accompany, and that is competent in understanding the logic of interdisciplinarity. And I was wondering, what is your experience on the competencies required to organize this kind of project-based learning courses or curricula?
At an interdisciplinary level?
I thought rather, how do you train your professors and teachers?
Yeah, but
prepare them for being ready for this kind of courses and curricula?
Nobody trained anybody during the 70s at Aalborg University. We had to figure out everything by ourselves, more or less. But we also have a lot of experiences today. It is so when I'm director for the UNESCO Center and professor at the UNESCO Center and on PBL, and we are helping out at many places around the world to implement PBL, and there are many myths, many concerns about moving from a more lecture-based system to a more problem-based system. I have not presented any research results because I can only say that the research results today, it is indicating that students, they are gaining competences at another level than compared to a lecture-based system, and also that they are learning, and the learning they have from projects, it is something that they remember afterwards. But what is really important in this process is that when I have my course, I'm running my course by the textbook. And it is so that when you start to work with more active activity-based learning, which project-based, problem-based learning is, then of course you don't have the same time to present what you normally are used to. So this is an issue because deep in our hearts, we think that what is presented is also what is learned, or maybe we know that it's not really learned what is presented, but it is important that I'm saying it. So it's really a question of trust and also an understanding of learning, that it's not, learning is where you can go deep into something. And when you go deep into something, what you have to take out of that deep learning, it's also the methodologies. So you can use the methodologies, the methods, for the next time you are going deep into a learning process. This is a much more complicated a way of understanding learning, you can say, because when you have textbook learning, it's more or less at the same level of Bloom's taxonomy. Whereas when you have problem-based, project-based learning, the learning outcomes will go much more up and down. And it can be very complicated actually to understand. What is really, really important here is that the way to work in a project, it's also how our engineers are working when they get out into work. So this is also a reason that what we need people from companies to come and give us students' response to actually to their PBL competences, because it's so important that they understand that what they are learning is also at Aalborg University and at a project organized university. It's also what is needed afterwards in the companies. And the companies are ahead of us, because it's actually the Danish companies now saying to Aalborg University, well, we feel that our employees, they are working too much in silos. They are not really good in collaborating from development to sales organization, or just a control engineer versus a computer science test. So we need somehow that our employees, they can work more across the boundaries. I just got a new project from Grundfos. Grundfos is a Danish pump companies. It's working with water. And they have given us or funded a project for 6 million Danish crowns. It's a little bit less than 1 million euro for actually looking into interdisciplinary collaboration. And the interdisciplinary collaboration, that is something that is difficult because there you do not understand what the other one is saying. If it is mechanical engineering and civil engineering, and that they share the same paradigm. So this is what I call a narrow approach, a narrow interdisciplinary approach. It's easier for them to understand what is going on. But if we go to much more to broader outside the engineering paradigm and go to humanities, our engineering students, I have to say, they're not always very polite. They feel all this qualitative experiences. What should we use it for? We cannot quantify it. But if we're going to do develop technologies that are much more customized, we need to have the qualitative approach. We need to understand human behavior. We need to have integrated humans into the technological development. But this is something where we are working on this. So it's not only a knowledge barrier, it's also a cultural boundary, I would say. They really have created pictures of each other already from high school, and that continues throughout life, I'm afraid. So this is something that we really try to overcome. But we do not do it because, on the cost of the deep technical knowledge. If engineers are not able to do deep technical do the deep technical understanding, we are out. Deep technical understanding is a must also in the future.
Thank you, Annette. You have two questions on the chat. One from John Jacob and the second from Fredo Smulders. I propose we start by the one of John Jacob. So I will just raise up the question, what kind of skills we need to concentrate or improve the broad interdisciplinarity mega projects? Could you comment on that? So I don't know if John Jacob want to add something, but
I'm not always, I'm from Europe. I'm not always so happy to say something very positive about the US system. But here I actually want to do it, because in the US system, they have an elective system. And 30% of an engineering degree goes for courses that are outside the engineering faculty. That means that there are a lot of restrictions and disadvantages by doing this, because it's the students who should actually connect things. But the good thing is that they come in to a design course where students from medicine, from humanities, from language, from art are sitting, and they are collaborating together with these students from other areas. So the reason why I give you this example is actually that understanding and openness is a very, very important piece in interdisciplinary collaboration. And we need the interdisciplinary collaboration. Otherwise, we cannot move ahead. We cannot move in one engineering track and one art and humanities track. We need to solve the SDGs, all the challenges that we have across the different boundaries. So openness is one thing. Facilitation is another one. And one of our big disadvantages at the university is that we have not educated our academic staff to work interdisciplinary. And as long as we cannot show good examples of how we are working across the boundaries, we cannot expect our students to do it. I'm so sorry to say, but again, it's something about academic staff and our own approaches. So.
Thank you.
Yeah.
There is another question from Frido. Perhaps Frido, you want to say it? Yes. And after I saw that Antonio has a question too. Frido, go ahead, please.
Thank you, Maxime. Thank you, Annette, for your presentation. First quick question. Nowadays, we're also talking about challenge-based learning, challenge-based education. Looking at your 2x2 matrices, I think it's a matter of naming. I mean, if it's very open-ended, it's challenge-based. If it's close-ended, then it's more problem-based, because then the problem is pretty clear. You agree on that?
Problems in Danish context is also broad, but I fully agree. And I think especially in the Netherlands, challenge-based education has had a huge rush because you have had Maastricht University. And nobody wanted at the engineering faculties actually to copy the Maastricht model, and that is called problem-based learning. So there are huge confusion about the concepts here. I fully agree.
And I agree that we have there is a rush forward also in the technical universities, Twente, Eindhoven, Wageningen, Delft. But the question that I have is that we have these dream teams in which students work a year to create a solar racing car to go to Australia and have fun and drive from one side of the country to the other side of the country. And they don't get any educational credits for it. But if you would ask them, what did you learn in this project? And they say, well, it was a great project. That's the first answer. And then the second, when you say, well, but what did you actually learn? Then they say, well, I learned how to collaborate with other people from other disciplinary educational programs. And then it stops. So basically, we don't give them credits because we cannot value or assess it at the academic level of learning.
What a pity.
Well, that's I don't know. It's a pity. I totally agree.
Yeah, but we can do that. An assessment system for problem-based, project-based learning is different than the normal written exams. So it is different. But we can do that, and we have no issues in doing that. Let me just say that co-curricular activities, if you asked me 10 years ago, I would have said, oh, this is really a way to avoid changes in the curriculum. But today I think, okay, why not do some of these co-curricular activities? But by doing that, you still keep the core traditional engineering. You keep it as it was 50 years ago, because you don't need to change. And maybe it is so that you don't facilitate the students very much in how they actually do these dream team activities. Maybe they are not used to a subject, a dialogue about the subjects, how they're using knowledge, how they're constructing knowledge. So if they're not used to it, if they don't have a concept for just doing it, then it's difficult. Exactly. Then you are back to the computer science student who are doing the code overnight and cannot explain what he is doing.
Well, basically, it also comes down to how to have enough staff that knows how to sort of coach and facilitate these students while they're in these projects. Because we have dominantly, let's say, disciplinary staff that is very knowledgeable about their own discipline, but they don't know about the cross-collaborative, cross-discipline collaborations. No, we don't have the staff for that. So therefore, it might is also sort of a chicken and egg problem.
Yeah, it is. But what we were very surprised by, it's actually our results from asking students what they learned by participating in both the narrow, more system-oriented projects and also the broad projects. It is that they understand their own discipline much better. And this is a storytelling, that our narrative, that we need to turn it a little bit upside down, actually, because it is by looking at this. I'm not going into social science. I'm here. Or I'm not in civil engineering. I don't need to learn about statics and material. I'm much more here. So they learn actually what they are, how their own discipline is scoping. Or I don't know if I can put it that way. Okay. Yeah.
Thank you. We'll take a last question, perhaps by Antonio, who had one, if I'm not mistaken. Antonio, please. And then...
Thank you, Anette, for your very interesting presentation and sharing your experience with us. I have one question in relation to the use of project-based learning. At least in our faculty, it's more common to use it within a given discipline, and is managed by the faculty responsible for that discipline. The question I have, how do you motivate in your university the faculty to engage in interdisciplinary project? Is this a top-down directive from the management of the school or the management of the course? And these interdisciplinary projects, all students of a given course have, when I mean courses, say mechanical engineering or civil, or all students will be engaged in this kind of courses. And what kind of physical settings do you need to, if you need any, to implement these interdisciplinary projects, to have students collocated in a given space too? Yes.
The first question, how do we implement it? Let me say that it's sometimes it's bottom up, and I would, as coming from Scandinavia, I would hope that I could tell you it's all bottom up, but it's not. This is a top-down decision that our students they have to learn to be able to work in interdisciplinary teams. This is the way that we will implement the SSH STEM dimension, the interdisciplinarity at the whole university. And we will do it by asking different program coordinators to find each other and to work together and do something that is meaningful for them. But the initiative comes from the top. And the initiative is also combined with that Aalborg University now will go in direction for a mission-driven university, both from a research side, but also from educational side. But if you look at most of the university's websites today, you will see mission-driven and missions nearly all over. But we are not doing it on selling out of the deep knowledge. We do it with deep knowledge, and I wouldn't say it's a T-shaped. It is deep knowledge, and then we try. They have to learn to collaborate. So the T-shaped, there are also a lot of knowledge elements in that in the bar on top. So it is a top down. So that was one question. Now I forgot the second one.
The second one was in relation to a special setting to implement this. We
have space. Aalborg University has a lot of physical space to facilitate students' group work. They are just using that space. But we also now are cutting a lot of space down because space costs money. So we combine it with virtual. But what is really, really important here, students, we can go in a much more digitalized learning setting, but they need to have a blended learning environment. So they need to have both a digital learning environment combined with physical space.
I agree.
Thank you very much, Anette, for the presentation and the discussion. I propose we proceed to the second lecture by Mikael Enelund. We'll try to keep the same time so that we'll have some small discussion at the end. Mikael, the floor is yours. Thank you once again to accept to present in such acrobatic situation.
Well, no problem, and thank you very much for inviting the TRACS leadership team to present TRACS here. And also thank you, Anette, for a very nice presentation. And it's really an honor to present TRACS in the same meeting as you present the PBL from Aalborg. And I guess you hear me quite well, and now I'll try to share my screen.
Yes, we can hear you perfectly well.
Always an adventure, actually, but let's try.
Yes, you can see your screen. It's perfect.
You can see my screen. All right, so I'm going to present the TRACS initiative at Chalmers. It's an initiative for reformed education at Chalmers. It's about elective, multidisciplinary or interdisciplinary courses and an innovative learning environment. And it all start with the background here. It all started about 3 years ago when the Chalmers is a private university, which is rather unique in the Nordic setting, and our owner foundation decided to invest in Chalmers, and they announced projects, and we had, it was an open call, and the education suggested a project to reform education, both when it comes to courses and learning environment. And it got approved together with a project in gender and then another in AI. So, and those are 10-year-long initiatives. And the one TRACS is for reformed education, as I said, and it was based actually on the trend analysis. And we had workshops with teachers, research leaders, students, deans, administrators, and also our industrial partners. And we identified 3 major trends that will influence education and already influences education, I would say, the complex societal challenges with increasing demands on interdisciplinary skills. So to be able to solve those challenges, we need to educate the students differently. They need to be able to work more together, cross disciplines, of course. But we also notice that we have changing needs and requirements from the students. They would like to more design their own education. So we need to be open for more individual choices within the education. But we also have changing requirements on the students. So they need to go out in industry and work more cross-disciplinary, as I mentioned. And also for the university, Chalmers is basically a program university, so we have programs for everything. And if we want to do changes in programs, if we would like to introduce new courses, new technology, new materials, it's a very long process actually. From IDEEE to have a new course at Chalmers in a program, it's like 2 years. And I trust you have about the same situation. Everything needs to be so regulated, and you have guidelines and principles, and also actually by the law actually. So we have to, so it's a very, very stiff system, I would say. So we need to come up with something that we could have new courses and new education with within much shorter time frames actually, just to be able to include new technology. In the Gothenburg area right now, we're a very, very strong push from the industry towards electrification of the transport sector. And I'm not sure you have heard of that, but we are going to build a mega factory for battery production just next to the Volvo plant here in Gothenburg. And of course, they need new competences then to be able to do this. It's so they push us really hard to educate both our students but also their engineers to be able to do this transformation from combustion engines to electrical drive lines, including this battery factory. And to meet those demands, we cannot come up and say to the industry, well, we could start a new education, we could, but it would probably take like 2-3 years, and then the students had to study for another 3 years. So maybe in 5-6 years or something like that. You understand, it's impossible. So we needed tracks for this. And so what is tracks? Tracks in short when it comes to the courses. So first of all, I would like to stress that tracks courses, the elective courses, are included in a regular course offer at Chalmers, primarily as elective courses, but also as extracurricular courses. And at Chalmers at master's level, all students have 30 ECTS as completely elective courses. So they can choose courses outside Chalmers, can also, of course, choose courses within Chalmers, and here is the space for tracks then. But we also have some elective courses already at bachelor's level, and they can use those electives for tracks courses as well. And very important here is that the tracks courses, they do not belong to any specific program, school, or department, and they are also open for all students from second year at bachelor's level up to master's and even PhD and alumni levels. And they do not, as I said, they do not belong to any specific department, program, or school. They are directly under the rector, you can say. And so also we can say that in this way, tracks is a fictitious department actually, but it has no personnel, no staff, no faculty. So we just are open. We are an arena for faculty to suggest courses actually. So courses are suggested by faculty in open calls, and we have a few requirements. The courses should be multi or interdisciplinary. They should have external stakeholders. They should be open for students from several several disciplines. They should be problem-based, and also they should include general engineering skills. And also the courses should focus on either contemporary societal challenges or more recent research challenges at Chalmers. And the model here is that the students are trained to discover, develop, build, and test and implement in a collaborative setting. Is based on the CDIO actually initiative, which is very strong here at Chalmers. And of course, admission criteria, prerequisites varies between the courses and are decided by the examiners of the course. The courses generally have teacher teams from many departments actually, and courses are taught in English also at the bachelor level. And to be able to handle this, to have this in our study administrative system, we have what we call umbrella courses, which is the framework. And the umbrella courses, they have general learning outcomes that are addressing professional skills, so general engineering skills. And then we can actually add more topic, course-specific learning outcomes for the specific course in very short time before the course starts. Actually, it could be only 2 weeks actually, but that's the extreme. Normally, we would say that it's like 3 months from the IDEEE until we can launch the course. And this is, of course, very important for us, and we have used this several times now when we have the push from the industry. And also, a TRACS course can only run for 3 occasions. Most often it will be 3 years, so you run the course once a year. But it's 3 occasions, so you can have the course every second year. Flexibility is really large. We can also have the course. It's not tied to any particular part of the academic year. We can have it as a summer course. It can run over the full year. It can run basically when it fits the teacher team and the students. So those professional learning outcomes should be satisfied by all courses. And I will not go through all of them here. It's about identifying and formulating architectural or engineering problems. It's about mastering problems with open solution spaces. It's about lead and participate in the development of new products, processes, and systems. It's about work together cross disciplines. But it's also about to identify cultural differences and work with them. Also about ethical aspects. And also it's about to deal with the impact of architecture and engineering solutions in a global, economical, environmental, and societal contexts. And it's also about being able to explain the solutions and then fulfill the project or course-specific learning outcomes. So we have those general umbrella courses in our study administrative system to be able to register students and give them credits and to be able to satisfy all requirements from the government and so on, also from the university. So, tracks here now in short. As I said, it's based on the trend analysis, and where we identify 3 main focus areas where interdisciplinarity or multidisciplinary is a key in all courses. So we have students from different educational backgrounds, but also from different educational levels, from second year at bachelor's level to master's PhD, and alumni in the same course. And well, this is also one of the few things that has come up in our evaluation as being challenging for the students. It's the tension between the different levels of experience, and primarily between bachelor and master level students, I would say. So this is really interesting, actually, because we haven't seen the same tension between alumni and PhD and master and bachelor, but between bachelor and master students, we can see some friction, actually. And we handle this through a dedicated resource from our department, Chalmers Department of Communication and Learning in Science. The teacher team from this department can support the teacher team in the course directly by having group dynamic exercises in the course, or they can train the teacher team to handle this, and they then handle it in the course. So we have two different ways here. Anyway, we strongly believe here that this mix of students on different levels is a good experience, both for the less and more experienced students, because it's similar to real work life, of course. And it's a situation that they will experience both in the beginning and also later in their careers. And our second key is collaboration, as I mentioned, collaboration with both industry, society, and the recent research at Chalmers. And we have very many tracks courses right now. We have 25, and they look different. I will give you some examples shortly, but depending on the course, it can include, all courses include both theory and practice, but sometimes we have a stronger focus on theory, and sometimes we have a stronger focus on practice. But both aspects are always present. And we don't really consider this as a problem, but we have a portfolio of courses that cover both aspects, but the focus varies within the courses, actually. And then another key is that all courses should include professional skills or general engineering skills that are applicable for all students, in contrast to the specialist skills that they bring from their programs. It could be that we have students from physics, and we have students from energy, we have students from architecture, we have students from marine in the same course. And of course, they bring the specialist competences, but then we also have the general skills. And then they apply the knowledge in, for example, a course in music engineering, that they can, for example, program Baroque music and or look at sound from a scientific point of view, and they can also work together and learn from each other. So tracks creates opportunities for the students to complement and deepen the technology knowledge depending on the interest from the students. And I'm just going to show you a recent quote from a student team in the course Music Engineering. And now I cannot read it myself since you have that. So I said that this course was a good amount of fun, and that's good. You learn better if you have fun, I'm sure. And the course involved a lot of learning for all of us, not only about music, but also about the psychology surrounding the music, its traditions, different culture interpretations, AI, the specific team worked with AI in music, and more, it was a great opportunity to organize and schedule work as a group, a fundamental skill for maximizing the impact one can have. So here we can see the mix between technology, society, teamwork. I think it's a good example. And to continue, sorry, just also have a slow computer today. Well, we also have support for teachers and also for students, actually, when it comes to the general skills. And we work with this with online modules for tax teachers and students. And here you can see a picture from our learning platform, where we have different modules. We have modules for ethics, equality, intercultural communication, sustainability, group dynamics, and also critical thinking and such things. And we have them, as you can see in the example here, for ethics at different levels. So we have an introductory level, intermediate level, and advanced level. And students and teachers use the modules depending on where they are in the education. If I already have gone through an introductory short course in ethics, I go to the level 2. And we do not enforce tracks teachers to use the modules here. It's just an opportunity for them, and they can use them, and the students can also use them themselves, actually, because they are structured as self-studying material. So we should also remember that tracks is a rather new initiative at Chalmers, and the teachers in the tracks courses are experienced teachers that have had project-based courses before. So many of the teachers are skilled when it comes to the teaching and practice general engineering skills in the courses. And also we think this is not exclusively for tracks courses. We like to offer this general engineering skills modules for all Chalmers. So we don't do this only for tracks, but it started for tracks, but now we spread it to the whole university. And as I said, I would say we are in the beginning. We have had courses for 2.5 years now, but and we are very open when it comes to accepting courses, actually. So faculty suggest courses, and we have a few requirements. As I said, it should be multi or interdisciplinary. We should attract students from several disciplines, and we should have a teacher team, and we should have problem-based learning. And to have a structure in this, we organize the courses under themes, and currently we have 5 themes. We have emerging technologies, we have sustainable transports, health and sports technology, sustainable cities, and sustainable production. And one interesting thing here is that those themes match perfectly the areas of advance at Chalmers, which are areas in which Chalmers has strong research. And we didn't know this beforehand, because also the themes were suggested in open calls. So we have a perfect match here. And also Chalmers is basically a research institute, I would say. 75% of our turnover is from research. And so tracks fit very well into this structure with the areas of advance. And I think this is a really good.
Oh, I hope the computer didn't crash too strongly. So Annette, you see. Okay, Michael.
Yeah.
Michael, we lost you for a few seconds. Sorry, with your.
Okay.
So if you.
Okay.
You were just elaborating on the importance between research and those track and how it fits perfectly with the program.
Okay. So I think I said basically everything here. Can you hear me fine now?
Yes. Yes.
Great. Thank you. So and then under the themes we have the courses, and the courses we have different sizes. We have introductory course for 3 credits, and then we have 7.5 and 15, and we have courses on basic and advanced level, just to be able to fulfill the requirements, I would say. And courses are small to medium large. We have 5 as the under limit, and about 50 students per course as the upper limit. And we have had students, and we have had courses with 5 and also with 50 students. And just here you can see a list of our courses this spring semester. And well, it's 14 courses, and I will not talk about all of them, but you can see we have a mixture here from very research-oriented courses to as conveying 2D materials into practice, fluid structure interaction, to more societal-oriented courses as music engineering, frugal design, and we also have 2 courses that we run together with other universities. We have technology, politics, and the society, which is together with University of Gothenburg, and then we have engineering across cultures and nations, which is together with Pennsylvania State University. And also we have, I would like to mention that the course in fuel cell systems, which is also a professional education course. So we run that both as a professional education course and as a tracks course, mixing professional engineers and students in the same course. And that course was also developed together with the industry quite closely. And just to give you another example, we have a course in data-driven product realization, which is developed together with our area of advanced production, which is this research organization here at Chalmers. And this course includes real-world industry projects in applied AI. It's about data quality, pre-processing, modeling, and evaluation. But it's also about business value and organizational design. And it's multidisciplinary teamwork and project management and methodology. This course was a very good course, I would say, and it resulted in thesis work for several of the students in the course, which can be the next step. And so here I also show you, we also have worked with specialization course packages within tracks. We have one example here, which is within emerging energy technologies, which is a very hot topic at Chalmers right now. As you can understand, I think it's in everywhere. And by tracks, we could introduce those courses with very short notice. We have a course within structural batteries. We have that course with fuel cells that I mentioned. We have a course in solar energy, from physics to societal impact. We have a course in carbon capture, which is a very active area of research here at Chalmers. And we have a course in battery system technology, which is coming up next fall. Another example of path is that we have an example of students performing their bachelor thesis within, for example, fuel cells. And then they take the tracks course within fuel cell, and next step we do the master thesis within fuel cells, and then they find a PhD position or an industry position. So we have a lot of spin-offs here actually, and we have seen that tracks actually attracts young researchers to suggest courses within their research. And then they team up with colleagues from different departments to run the courses here. This kind of courses are truly multidisciplinary because it involves several disciplines. And to start to sum up here, we have seen several advantages and opportunities here. And first of all, for students. So the students can here apply for 1 up to 4 tracks courses to create a profile. And we already have had 1 student actually having 5 courses. So that's also possible, but in that place, in that situation, you need to replace a course in the program, and a few program heads have accepted that actually, that they can replace mandatory courses with tracks courses. So the students can influence their education, so they can make the individual choices, and they can practice solving interdisciplinary problems and challenges in teams with students from different disciplines at Chalmers, but also from different levels, together with alumni and professional engineers, and even together with students from another university. So, and also it's a opportunity for students to take part in the latest research at Chalmers, or in the latest industry development in the education. And of course, for faculty, this is an opportunity to connect students to their research and development. And we have seen that recently recruited assistant professors here at Chalmers, they have, it's not very, but it could be difficult for them to begin to teach actually, because they are recruited here as assistant professors, and courses in programs are often run by the same professor year after year after year, and then we have young assistant professors that want to teach and want to also, they need to merit themselves within teaching, and they are so within tracks they have opportunities to develop courses closely related to the research, to try out the pedagogical ideas, to merit themselves in teaching, and also, of course, to identify students for thesis work. So this is, and we didn't realize this from the very beginning when we started with tracks, that this would be so popular actually among young assistant professors actually. And also we have a number of assistant professors here at Chalmers that have very good benefits actually. So it's a strong competition when we hire those assistant professors, because they got support for a number of PhD students from the very beginning, and then we saw this, that they also would like to take part in education, which we are very happy for, of course. And for the university itself, it's an opportunity to very quickly introduce new education in collaboration with research industry and the society. So we can educate in new technology, we can introduce new materials in very short time frames, and can be very responsive for requirements, needs, and demands from industry. As I mentioned, electromobility is just one example, but a very, very current example for us, since the push is enormous, I would say, right now. It's also an opportunity for Chalmers to test new educational structure, new organization, to having just courses not tied to a specific program or discipline or department or school, which is a new thing for Chalmers actually. So also we can test new pedagogical models and such things. And for the industry and other organizations in the society, this is an opportunity to contribute to education with everything from projects, cases in the courses, or to suggest courses, to take part in the teaching of courses, to have their personnel taking the courses, and also for the industry to get access to new technology to professors at Chalmers. And another part of the tax initiative is to the development of a new learning environment. So we have built a new learning environment here at Chalmers for exponential learning. It's a huge makerspace, you can say. It's 2,000 square meters with workshops for textile, metal, wood, rapid prototyping. We have a film and sound studio. We have electronics lab. We have computer lab. We have VR lab. We have a physiology lab. And we have open areas for teamwork, exhibitions, and so on. And this learning environment is for all tracks courses, but also for other courses, if available, if the facilities and resources are available. It's open also for all other courses, and also for all students at Chalmers. Actually, it's also open outside school hours. So between 8 and 5 in the afternoon, it's reserved for coursework, but after 5 o'clock until midnight, it's open for students to be there, working with school projects, but also with more private projects. And it's also a meeting point for education, research, industry, and society. So we have several events with industry already, and we opened up this in March, actually. So we have only been running it for like 3 months, since we have had like 4 or 5 events with industry already. So it's and the threshold to be here is really, really low. So we welcome all students. And after school hours, we have a student organization taking care of the facility. And we also, of course, have courses in handling machinery and labs and such things. And of course, safety. So this concludes my presentation of the TRACS initiative at Chalmers. I'm happy to answer your questions, comments.
Thank you very much, Mikael, for the presentation and for showing us that TRACS is not only courses for students, but also a way to transform Chalmers, the university, to test, experiment, and etc. Thank you very much. So if same thing with Anette, if there are questions, please raise your hand or put them in the chat. So same thing, the first question, always difficult. Pascal, yes, if you want.
I can try the first question. Thanks a lot, Michael, for this fantastic presentation. Just like in the case of Anette, what is striking is the parallel you have between the course and the transformation of the university. We feel that there is a spirit behind the course that is going really beyond just some hours to students. And so really that's interesting, this movement that you're describing. My question would be on the notion of project, finally, because the kind of issues you give to the students are very demanding, very open, and we know from designs and theories and practices that to such, say, problems, but it's probably not the good word, that there are many solutions. And I was wondering, how do you organize a trade-off for the teams between the idea that they have to explore broadly and to some extent at certain moment, because of the curricula and the pedagogical logic, you might have to converge. So how do you organize this dual process? If you organize that, I have no idea.
Yeah, well, it's actually varies very much between the different courses. Now, in the very beginning, we have a very wide selection of courses, as you can see. Some are very, very open, and we support students with the methods to handle open problems, of course. And also, I didn't mention that, but the courses are teacher intensive. So we have a lot of manpower in the courses because we have extra funds from the owner foundation to do this. So you have to, I didn't mention that, but we have substantial money, so to say. But so we guide the students, but also we have other courses that the students are more self-directed and guide themselves. All right. So it depends very much on the course, but we have a toolbox for them, of course, and we have different tools as peer learning and such things also in the courses, of course. And we, as I said, we have different levels of experience in the courses. We have PhD students in most of the courses, in particular in the courses that are more related to the current research, and they are expected to take more leading roles in the student teams, of course, as compared to the bachelor level students. So I think this is also one nice thing to have. And sometimes we can see that the PhD students more or less use the other students as manpower. But I think it's a good thing, and because the students at the bachelor and master's level will perhaps end up as a PhD student, and then they can train in leading others. And also, I must say that in a few of the courses, we have surprisingly high level results actually from a scientific level. So we have had scientific papers actually from the courses, co-authored between faculty and students.
Thank you, Paul. Yes, I see you.
Yeah, thank you, Maxime. And Mikael, thank you for a fascinating presentation. You mentioned that new assistant professors get merits for participating in tracks. Two questions. How many of them actually for courses within tracks? And secondly, how do the more established faculty react to the fact that these bright, young, new assistant professors are not making themselves available to their established programs?
I think we are quite, most of the established faculty are quite happy with this situation actually, since they can keep the courses themselves. It's very, well, I think they like to have the same course year after year, and they really don't let the young researchers take over courses. Actually, we have that's a problem actually at Chalmers, that the same professor has the same course year after year, and then we have tracks, and then we can have the young enthusiastic new assistant professors coming and developing projects and courses within their area of research. And as for the number, right now we have 25 tracks courses, and I would say that half of those courses are developed by assistant professors and the rest by more established professors at Chalmers.
Thank you.
I see questions in the chat. So one from John Jacob, I think. Yes, could you, so hi Michael, thank you for the presentation. Could you please comment on on the creating new education materials for university, combining research lab and industry.
Yeah.
I don't know if John Jacob want to ask the question, or I think there are microphone problems, is that if I remember well. So yeah, you probably see the question we can.
We one example is the structural battery course, which is about structural batteries, which is a area of research here at Chalmers. And the battery is not only storing energy, it's also load bearing structure, and we have a lab for that here. And also we know we work together with Volvo Cars about this, and also about aircraft manufacturer. So we just come here, meet, and we have guest lectures and such things. And I think it's just natural way of working here, actually, because we are located here in Gothenburg. So we have to work together with the industry, since Gothenburg is the center for the manufacturing industry in Scandinavia, and we have the major companies here having headquarters and development offices. I'm not sure if I answered this question really, but because also most of the research here at Chalmers is carried out together with industry. Actually, it's very difficult to have a research project that is just fundamental without any connection to industry right now. So it's most of the research is supported by the industry.
There is other question from Gaetano in the chat, but I know that Anette will be leaving us within 5 or 10 minutes or so. So I don't want to miss the opportunity, Anette, if there is a last question for Anette, or if Anette, you want to comment or react on the presentation we just had, as I know you will be leaving soon.
Thank you very much, and thank you, Michael. It's amazing how Chalmers and Aalborg University, actually, we are on the same track. I think you have built in more industry collaboration. Our industry collaboration is more randomly, depending on research projects and depending on students' projects and so on. In mechanical engineering, they have a company project every semester. But otherwise, you have a structure for this in a totally different way. And I think we should sit together and figure out what we are doing with these professional competences and generic competences, because it's actually not easy. So what you are doing, it sounds very structured and easy. And also at MIT, I know that they have, they don't call it tracks, they call it something else. I forgot.
It's neat.
Neat, yes, but they don't call it a track that they build up. But it is a very clever implementation, I would say. And the reason why it's clever is because you build up something new across different programs. And they have done the same at MIT, and they do the same different places around the world. And it's clever because you actually move resources from the traditional courses into the new established track. It's a way of changing the curriculum slowly without having all the conflicts. So I know there are conflicts. I know this is not easy. But it's a clever way of doing it. If you're coming from a very traditional lecture heavy system where people are used to repeat their courses year after year, and then to do something new. And also, it's very clever that you have put in the reward for assistant professors, and you also should do it for associate professors, because this is also a way to give it more prestige, actually. So you have really tried to use all the buttons that you could. So congratulations. I hope to meet you very soon, Michael, somewhere in the world.
Maybe on Iceland.
No, I'm not going to Iceland. My colleague is Ewan. So yeah. So thank you.
Yeah, thank you. I think this is really bottom up, since faculty suggest courses, suggest projects, and programs are very much top down, and so this is a way, actually, an opportunity for faculty.
So thank you very much.
You're welcome.
Thank you, Annette, also for all the presentation and all. Gaetano, you had a question that you raised on the chat. Perhaps you will.
Yeah, sure. Well, thank you, of course, again for the presentations. I think that the first question I made was suitable also for Annette, but I mean, definitely for Michael. And it is on the side of involvement of external organizations in general, companies in particular. I think that also here in Milano we have quite a solid experience of inviting the companies to offer challenges, to even to deliver some lectures on specific technologies or specific content, definitely in tutoring project activities. But what we're struggling is how to, if, first of all, and in case, how to involve them in the assessment. Because, I mean, of course, there are both positive and negative things. If we really want to have our students achieve certain learning objectives that we consider external to be more suitable to deliver, then they should be also involved in the assessment. But at the same time, we know that it is not part of the business. They are, I mean, robustness is not always granted, because of course they have other priorities. So if you have any best practice in that direction?
I would not say best practice. External stakeholders are not directly involved in the assessment. They give feedback on the solutions and feedback on the reports, and they participate in the presentations and such things. And but the assessment, the grading, is carried out by the teacher team.
Okay.
Of course, they also give feedback, but not. I would not say not on an individual basis. More on the performance of the team. Okay. And then we also at Chalmers we need to grade all students individually. We cannot.
Of course, and that's the point.
That's the point. So we have different tools for this. Of course, we use peer grading and such things also too, and we also have the final grade is composed by different components. We have the team achievements. We have the process. We have contribution reports and such things. So, but it's really tricky to. And we also have specialists supporting the teachers in this grading procedure. And we have workshop and such thing how to do this. But most often all members of a team get the same grade.
Yeah.
And we also tried the students to write reflections, and we have had in some courses we have quizzes. So we have a variety of assessment methods, but it's very difficult.
Yeah.
And ideally, I would say we shouldn't have, we should only have passed, non-passed, but we are not allowed to have that. So.
Yeah, in our case, we have exceptionally for one course, it could be a pass and non-pass without specific grade, but of course, this cannot be on, I mean, the entire curriculum for obvious reasons. And the second, if I may, is very practical about motivating colleagues.
Yeah.
I mean, when you differentiate between, you call them umbrella courses.
Yes.
With respect to more specific ones, because it's quite evident that there will be a different kind of involvement, engagement of the students, opportunity to keep working with them, etc. So, I mean, if you have any strategy to handle this.
The strategy is rather simple. We put a lot of support for the teachers, both from our communication and learning department, but also from us and from the administrative unit. We have special administrators helping us, of course, and also we for teachers in tracks, they have full compensation for the working hours in tracks. So we have a lucky situation that we have funds covering everything they do actually. So they don't need to do this in evenings actually. So we support them by hour in developing the courses, and then they have ordinary payment to their departments for running the courses. And we have the infrastructure as well, you know, the learning environment that is available for them. So we do everything we can, so it should be easy for the for the teachers when it comes to everything around the course.
Thank you.
We have two last questions on the chat, one from Antonio and one more broad, perhaps from Frido. Antonio, please.
Yeah. Thank you for your presentation. I appreciate very much your track programs. And my question is a quick one. What is typically or how popular are the tracks course among students? Yeah. And what is typically the number of credit units that students take as a percentage of the total number they need to get to the degree?
Okay. So we have been running this for 2.5 years, and now we have this year, academic year, well, it's the year has ended, but we had 400 students in tracks. But the total number of students at Chalmers is 10,000. So, yeah, but but then if we and most of the students, I will say 75% of the students are from master's level. And at master's level, we have 120 credits, and they normally take 15 credits within tracks.
Thank you.
And they have, as I said before, 30 credits elective at master's level. So 1/4 are electives. And that they take 15 credits within tracks.
Frido, you had one question also.
Yeah, thank you. Thank you, Michael. I was thinking of, as far as I understood from your presentation, you were focusing very much on cutting edge technologies in these courses.
In some of the courses, I would say we have more, we have the full smorgasbord, as we say in Sweden.
But there's a lot of content in there as well, that they work on the content.
Yes.
My question would be, how do you assess the learning that they do beyond the content in terms of collaboration with industry, collaboration with teams, etc.?
Yes, we have, me as a director of tracks, I put full trust in the teachers, of course, to handle this, but we also check that they do it actually. And different ways in different courses, but most often they have a written, always they have a written report, of course, with contribution report. They have presentations, and they also write reflections. So students reflect on their own learning. So they kind of reflect not only on the learning from a scientific point of view, but also the learning from this more general point of view.
And is any theory related to that about collaborative learning in an, let's say, project situation?
Yes, of course, different. We have specialists in that, of course, but not in all courses. So, and we have the specialist from our communication and learning department helping out the faculty in the courses. Yes. So, but also we have peer teaching and peer grading as a tool. So we have a mixture of tool, and we have the teachers taking the more the role of supervisors. So they grade the process. Mm-hmm. And some courses use rubrics for that. But we, as I said, we have a smorgasbord and we have variety of courses, and we use different tools in all courses. But then we put a lot of trust in the faculty actually and some of the umbrella more general learning outcomes are more easy to grade, and some are more difficult, of course. But when it comes to mastering open problems, communication, and such things, I think it's straightforward. It's more difficult to grade ethical reasoning, for example. That's really difficult. So I think often it's just enough that the student reflect on it. And so it's just a checkpoint that they do it actually. Do you have any suggestions for us when it comes to grading ethical reasoning?
Yeah, that's a challenge.
Yeah, so I think
it's very situational.
Yeah, and so I think it's a checkpoint that they do it actually. So it's very difficult to put a number on that, but it should be in their reflection.
Yeah, how far they are holistic in considering the situation that they're in. Yeah. Okay, thank you very much, Michael.
Thank you.
Thank you, Michael. Indeed, so we are at the end of the conference session. So once again, thank you very much for presenting tracks. Once again, a warm thank to Annette who had to leave us a little bit earlier. Thank you also for those who are still here at the end of the conference. With the member of the steering committee of IDEEE, I propose that we proceed and stay on the same link for our small and short meeting to organize the rest of the community. For the others, once again, a warm thank you, Mikael. And the next conferences is not planned yet, so we'll try to have other theme going on. So we'll keep you posted. Thanks also to Stephanie who organized the communication and the invitation and the website. So a very warm thank you to Stephanie who made it possible for everyone, and for the sharing of the previous conferences. So once again, it's 6 o'clock. That's perfect. Mikael, thank you very much.
Thank you, and thank you, and you are all very welcome to Chalmers to visit us. So.
Thank you.
Bye. Have a nice evening.
Thank you.